Difference between orbit, suborbit and orbital. So what is an orbit? An orbit is a well-defined circular path in which the electrons revolve around the nucleus of an atom. An orbit is also called as energy level or shell. Here is a diagram of a shell. In the center there is a positively charged nucleus, while outside there are different shells which are represented by K shell, L shell, M shell and N shell. Okay, K shell can accommodate a maximum of 2 electrons, L shell can accommodate 8 electrons, M shell can accommodate 18 electrons and the L shell 32 electrons. We can calculate the maximum number of electrons in any shell by using the formula 2n square. Suborbits. A suborbit is a subdivision of electron shells or orbits separated by electron orbitals. Suborbit is also known as subshell or sub-energy level. Subshells are denoted by S, P, D and F, where S is a representation for sharp, P for principal, D for diffuse and F for fundamental. Now let us look at the diagram of the subshell. Note that the number of the electrons in the shell must be equal to the number of the electrons in the subshell. Now in the K shell we have only one subshell, that is 1s, while in the second shell, that is the L shell, we have two subshells that are 2s and the 2p, while in the third shell we have 3s and the 3p subshell, and so on. So what are orbitals? It is the three-dimensional probability space around the nucleus of an atom where the possibility of finding the electron cloud is maximum. Types of orbitals: S orbital. S orbital is spherical in shape and is 1 in number. P orbitals are 3 in number, that are px, py and pz. D orbitals are 5 in number, that are dxy, dyz, dxz, dz square and dx square minus y square. F orbitals are 7 in number with a complex structure. Relation between orbit, suborbit and the orbital. In simple words, we can say that this will give us the complete address of the electron. For example, if we want to find out the address of the Mr. X, then we must know about the city in which he lives, his colony and the house number to reach at the specific place. Similarly, if we want to find out the address of the electron, we must know about the shell in which the electron is, about the subshell and also the orbital of the electron to reach at the place of the electron.